Okay, let's talk a little bit about linear sequences. And here's an example of a linear sequence. And one of the things that you're going to find about linear sequences is that they have a common difference. Common difference means that they go up in the same amount every time. So, for example, in this sequence we've got here, if you check the difference between all of these numbers, you're going to find that the common difference is +2 because we're adding 2 every time we go up. Okay, so that's a linear sequence. If we were to plot this on a graph, we will get a straight line, so we call it a linear sequence. So let's not get ourselves bogged down too much with that. Let's look at what we're required to do. So in the sequences, we need to find three things. First of all, find the next two terms in the sequence, which is fine, that's easy to do. Find the nth term. The nth term is the formula that makes the sequence work. And last of all, we need to find the 50th term in the sequence. So in this first one, let's start by finding the first two terms. So we can see it's going up in twos, just adding 2 every time. So if I add 2 to 11, it tells me that the next one should be 13. And then if I add 2 to that 13, the next one should be 15. So that's fine. That's the easy part done. Now the next thing that we need to do is find the nth term. Before we go on to find the nth term, let's look at a few things. Well, these are my terms of my sequence. This is the first term, that's the second, that's the third, and so on. And I can write it as such. So I can say that of the sequence that I've got there, this is the first term, so I'll put first, this is the second, that's the third, the fourth, and so on. Okay, we've just done, this is the sixth and that's the seventh. Okay, and all of these values are my n values. Okay, so I'll call these values my n values. So probably just jump straight into it, I think. If the sequence is going up in twos, then immediately you write 2n. And what I like to show students is just basically have a think then. What would be the term that comes before that 3? Well, if it was going up in twos, then it had to be something plus 2 to give us 3. So this has to be 1, and all I need to do is add that 1 there. Now this is my nth term. Let's see if it works. If it works, then we should be able to get back all these answers here. Now remember I just said to you that these values are my n values. So it means therefore if I substitute 1 into here for n, then I should get the answer of 3. If I substitute 2, I should get the answer of 5, and so on. So let's take a random one. Let's put 3 in. Okay, so I'm going to replace this letter n with the number 3. Let's do some working out over here. So 2 times 3 plus 1. All I've done is remove the n and put 3 in its place. Now I should get the answer of 7. Let's see if it's going to work. Well, 2 times 3 is going to give me 6. And then I've got that plus 1 on the end, so 6 plus 1 is 7. It looks like my nth term is working. Let's try a different one. Let's try when n is equal to 6. Now my answer should be 13, so let's have a look and see. So in other words, replace this n with the number 6 and I should get 13. So let's have a look. So 2 times 6 plus 1 is equal to, well, 2 times 6 is 12. I'm using BIDMAS. You can't just add first, you have to multiply first. 2 times 6 is 12. So there's my 12. Plus that 1. So that's my plus 1, and that gives me 13. So I know that this nth term is correct, and this is the term that makes this sequence work. So far I've answered two parts of my question. I have found the next two terms, here they are, and I've found the nth term, here it is. The last thing I need to do is find the 50th term. So in other words, what this question is asking me, if I was to carry on this sequence on and on and on and on and on, all the way to the number that's in the 50th position, what would that number be? Well, since I know that this is the nth term that makes this sequence work, I'm just going to replace the n with the number 50, because just as you saw, when I wanted the third term, I replaced the n with the number 3, and it told me that the third term was 7, which was correct here. When I wanted the sixth term, I replaced the n with the number 6, and that gave me the sixth term, which was 13. So now I want the 50th term. So here we go then. So this is part C of the question now. This was part B. So part C of the question, replace the n with the number 50. So here we go, 2 times 50 plus 1. That's going to give me, well, I need to do bid mass first. 2 times 50 is going to give me 100 plus 1. So my final answer is 101. And this is the answer in the 50th place. Okay, was that straightforward enough? All right then, let's see if we can get a few more to try out, and then you can try some. Okay, so here's our second one, and let's have a look at what's going on with this one. So we're going to do the same thing. We're going to find the next two terms, then we're going to find the nth term, then we're going to find the 50th term. Okay, so let's go then. And the next two terms, well, before we can do that, let's see what's the common difference. How is this sequence going up? Can you spot it? We're adding 8 every time, adding 8, adding 8, and so on. So if we're adding 8, remember what I said before? The minute you see that it's adding 8, then all I need to do is add 8 to get the next term, which is going to give us 34. And then we add 8 again, and that's going to give us the next term, which is 42. Okay, so that's brilliant. So we've got all that and we're done. So that's the part A of the question done. Part B of the question now, find the nth term. Well, I already know that the sequence is going up in 8s. So the minute I see that, I immediately put 8n. And then remember what I said before as well? Find out what would have come before. So if this is going up in 8, adding 8 every time, what would have come before? Well, if you think about it, if I go to 2 and I count back 8 steps, it should take me to -6. So that should be -6 there. If you're not sure, draw yourself a number line and then check. Okay, so that takes us to -6. This is my nth term. So I always like checking to make sure it works. I think that's a good idea to check. Okay, so this is my first term, my second, my third, my fourth, and so on. I'll just try one. So what we're going to do is let's try the second term. So if I change the n to 2, I should get the number 10. So let's have a look and see. 8 times 2, take away 6. Well, 8 times 2 gives me 16. So 16, take away 6 is 10. So I'm happy that that's my nth term. Okay. All right, good. Let's answer part C of the question then. Part C, find the 50th term, the 50th term. So we're going to change n to the number 50. Okay, and I should put that we're finding the 50th term. Okay, lovely. So Well then, let's have a go then and see what happens. So we need to work out this bit first here. So 8 times 5 is 40. And then we add a 0. So 8 times 50 must be 400. Take away 6. And that's going to be equal to 394. So, long story short, if this sequence was to carry on and on and on and on and on and on until you got to the number that's in the 50th place, the 50th number, then that 50th number is going to be 394. Okay, right, let's do one more, and this time I might choose a sequence that's decreasing this time, just to show you what might happen. Alright, at any point in the presentation, feel free to pause the video and have a go for yourself. You don't have to wait for me to do it. So yeah, anyway, let's have a go. So first things first, find the next two numbers in the sequence. Well, see how the sequence is going up or down. And in this case, the sequence is going down all the time. We're taking 3 away. Okay, taking 3 away. So what will be the next two numbers in the sequence? Well, if we're taking 3 away, then that has to be 3. And this one has to be 0. Okay, and that should be pretty much straightforward. Okay, so next step then, find the nth term. So this is part B, find the nth term. Well, since it's taking away 3 every time, immediately, like I've said before, minus 3 times n. Whatever the common difference is, you just multiply it by n. Okay, then the next step is find out what would have come before. What would have come before if we're taking away 3 all the time? Well, it had to have been 18 there. So, and it's a positive 18, so plus 18. And this is the nth term. Now, let's double check something. This is the first term, the second term, the third, the fourth, and so on. Let's try and make sure it does work. So let's try, let's try 3 this time. Let's try the third term. So if I change this n to 3, I should get the number 9. So let's have a look and see. Minus 3 times 3 plus 18. Work this bit out first. Minus 3 times 3 is going to give me minus 9 plus 18, which does work out to be 9. So I know that my nth term is fine and it does work. Okay, now let's go and find the 50th term. All right, so the third part of the question, find the 50th term. Now we're going to replace the n with the number 50. So if this sequence was to go on and on and on and on and on, what number is going to be in the 50th position? All right, here we go. So minus 3, 50 there, times 50 plus 18. Well, use your BIDMAS to work it out. That minus 3 times 50 is going to be minus 150. And then we're adding 18 to that, which is going to give us minus 132. Okay, and that is now done. So if the sequence was to go on for a long time, all the way up to the number 50, then you'll get 132. All right. Okay. Last of all, I'll tell you about a different kind of sequence and then I'll end the video. Okay, here's a different kind of sequence. Let's say I am using some matchsticks to make a sequence. So that's my first one. And on the second one, I do that. And then on the third one, I use what I had before, but now I do that. And on the fourth one, I used what I had before, which was that, and now I do this, and so on. Well, This is my first term, my second, my third, my fourth, and so on. And you might be asked to draw what the next one might be, the next one, okay? So you draw what you've had before, everything that you've had before, well, the last one, and you basically just finish that off. So that's going to be the fifth term here. Well, let's look at our matchsticks, because our matchsticks are actually making a sequence. And I'm going to write the sequence down in red. On this first one here, we've had 3 sticks. On the next one, we had the 3 sticks plus 2 more were added, so now we've got 5 sticks. On the next one, we had 5 sticks, 1, 2, 3, 4, 5, and then 2 more were added, which gave us 7 sticks, and so on. So you can pretty much guess that the next one will be 9, then the next one will be 11. And this is clearly making a pattern. You can see that the common difference would be that 2 is added every time. So what was I saying all along? The minute you find a common difference, you just multiply it by n, so you get 2n. Okay, and then we start having a think about what would come before. Well, if it was 2 that we're adding all along, then this had to have been a 1 there, so plus 1. Now this is the nth term of the sequence, so that's my nth term. I can now use this to pretty much check for anything else. Like, for example, if somebody had no time on their hands and they just wanted to play around with the sticks, how many sticks or how many matchsticks would you get in, I don't know, the 15th term? So if they carried on building these little matchstick patterns and you go all the way to the one that is in the 15th place, how many sticks would it have? Well, same as we were doing all along, change the n to the number 15. And so I'm going to write the 15th term, or the 15th pattern, or the 15th design, whichever way you want to call it, is going to be 2 times 15 plus 1. Well, you can work out your 2 times 15 there. That's going to give you 30, and then plus 1. So it means that there's going to be 31 sticks in the one that's in the 15th place. Okay, so I'm not going to do any more on this. There are loads of other designs that you might have. You might actually have, I don't know, people sitting around a table. So you might have something like that. But then they decided, okay, we're going to join the tables together. So you might find that they joined the tables together, and now you've got this. Okay, and then they might say, oh, we don't have enough, so they might join the tables, join another table again to that. So now you've got 3 tables, and now you've got something like that. And then they might say, okay, what if we had, I don't know, 10 tables together, how many we're going to have? So you can strictly spot a sequence there straight away. There are 6 people sat at this table, 2, 4, and then 6 there. So you've got 6 people at table number 1. But if you join the tables together, now you've actually got 4, 8, 10. So now you've got 10 people sat at this table. Then you join another table on here, and now you've got 6, and 6 is 12, and 2 makes 14. So you can clearly see the pattern is it's going up in 4s and so on. So I'm not going to work out the nth term for it. If you want, pause the video and work it out yourself. But yeah, so pause it there, have a go. But in case you don't, then you can clearly see the nth term is going to be 4n plus 2. and so on. And so I can now use that to work out how many people will be sat at 10 tables if I wanted to, and so on. Okay, so that's all for now. Later on I might do another linear sequence video on what to do if you're trying to find out if a particular number will be in that sequence. Okay, all right guys, I hope that was good enough. I hope that you've learned something from it, and feel free to ask me any questions in case you're stuck.